Hey guys, in this video we're going to be seeing about bitwise operators, ternary operators, and special operators. Now let's get started with bitwise operators. To understand the function of bitwise operators, you need to know binary. Binary consists of ones and zeros. Let's get started with the code. Now I explained logical and, or, and not in the last video. If you guys didn't see it, please check it out. You need to know it for bitwise operators. Now first, I'll initialize two variables. Let me give this value as 5 and this as 9. Then int result is equal. Now how you perform bitwise AND is two or more variables and an ampersand between them. First binary ampersand second binary. Now let's print the result. Now let's save it and run it. Oh, put a capital here and a lowercase in the result statement. Now let's run it. You can see the result is 1. Now I'll explain why. As you can see, our first binary is a 5, which in binary is represented by 1, 0, and 1. And our second binary is a 9, which is represented as 1, 0, 0, 1. Now we're performing bitwise AND. It's better to line up your variables like this. Now the first one here is actually a 1, and if it's a 1 there, it means it's a 1 because it's 2 power 0. The next digit is 2 power 1, which is 2. So if there's a 1 there, it's 2. And similarly, it's 2 power 2 here, which is 4, and if it's a 1 here, it means it's a 4. And you add wherever there's ones. So that's how you read binary. So AND means in both operands there should be a 1. In this case there's a 1 here, a 0, a 0, and if there's nothing here just put a 0. So it's a 0. So as I said before, this is 2 power 0. Sorry, I'm using a trackpad, which is equal to 1. And that's how you get the result. Now similarly, there are other bitwise operators. Let me just open it. Let me just open it and put a vertical bar like the last video, which means OR, which is similar to logical OR. Now let me save it, close it, and run it. No errors, 8 are out, and the result is 13. Let me show you how. Let me just erase the previous result. So this time we're performing a bitwise OR, which is a vertical bar. Now OR means there should be at least 1, 1. It can be a 0 or a 1 or a 1 and a 0, and the result will still be 1. So there's two ones, which means 1. There's a 0, so 0, a 1, and another 1. I don't think you can see clearly. So this is 2 power 0, 2 power 1, 2 power 2, and 2 power 3. And you add all these up, which is equal to 1 plus 2 power 2 is 4 plus 2 power 3 is 8. So 8 plus 4 plus 1, which is 13, which is the result that we got. Next bitwise operator is known as Bitwise Xor. Now, I didn't explain the Bitwise Xor table, but I'll show it now. Now, Bitwise Xor is denoted by this little caret. Now, let's save it and compile it and run it. The result is 12, and I'll show you how. As mentioned previously, the first binary was a 5 represented like this in binary, and our second binary was a 9, which was represented like this, and we're doing XOR. Now, as you saw from the XOR table, if both the operands are same, as in 2 zeros or 2 ones, the result is a 0. Otherwise, it's a 1. So we have 2 ones, which is a 0, 2 zeros, which is a 0. Sorry, I'm using trackpad. A 1 and a 0, which is a 1, and a 0 and a 1, which is a 1. So this is 2 power 3 and 2 power 2, and we add that, which is 2 power 3 is 8, and 2 power 2 is 4. Sorry, that looks like a cross. So when we add this, we get 12, which was the result that we saw. There's another one. There's actually 3 more. Let me open up the code. Now, as we saw from the previous video, we have bitwise not, which is represented by a hilde. Let me just delete this, save it, close it, and run it. You can see the result is a -6 in binary. So what a complement does, it makes the zeros into ones and ones into zeros. But in binary, there are different notations such as ones complement, twos complement, and etc. So this was our first binary number. Now it became 1, 0, 1, 0. So usually in 2's complement, if this is a 1, that means it's negative. And this is not 7 minus 1, which is 6. So we get the result. Next, we explain the next bitwise operator, which is left shift. In this, the first operand is a binary number. The second operand is how many bits to shift it by. Now, a bit is a digit in binary, and 8 bits is known as a byte. Shift value. If I want to shift it by 2, I put first binary, and we have right and left shift. Now right shift is 2 arrows to the right, and then the shift value. Let me just save it, close it, compile it. I forgot semicolons. I keep doing that. Yeah. Let me save it, compile it, and run it. You can see the result is 1. Now I'll explain how. So 0101 was our first binary, and we shifted it to the right twice. So what it becomes, this one goes here twice, and this one is shifted here. These zeros and ones are erased, and each time it's shifted, this value becomes 0, or a 0 is copied to the most significant bit. The most significant bit is the bit on the leftmost side of the binary number. So eventually it was 0, 1, 0, 1. When it gets shifted once, 0 is copied to the most significant bit, and everything else is shifted to the right once, and the least significant bit, or the bit on the rightmost side, is erased. So we shifted it twice, so this is the second time it's shifting. So this is our result, which is actually just a 1. Now the next thing is left shift, which is denoted by 2 arrows to the left. Let me save it, close it, and run it. And the result is a 20. Now let me explain. Usually binary numbers are considered in bytes, and if we don't give the full byte, it fills in zeros wherever you didn't enter. So when we gave a 5, the system assumed it like this. Now when we're shifting, it becomes, here when we shift left, the most significant bit is erased each time, and the least significant bit is replaced by a 0, or copied by a 0. So it becomes like this. And we shift one more time, so this is the end result. So this 2 power 0, 1, 2, 3, this is 2 power 4. And this is a 2 power 2. So that is a 16 and a 4, which is a 20, which was our result that we saw earlier. Now that explains bitwise operators. Now let's go to ternary operators. The expression for ternary operator is condition question mark statement colon statement. Now usually a condition returns a 0 or a 1, 1 saying that it's true and 0 saying it's false. So if this condition is true or it returns a 1, the first statement is executed. If it's false or returns a 0, the second statement is executed. Let me show you an example of what it means. We have 5 and 2 here. I don't think we need to store it in a variable actually. Save it, close it, and run it. Oh, yeah, I forgot to erase the other result. Now let's run it. Oh, sorry. You can see that it says first statement, which means the condition that we gave was true. Now let me reinitialize the values so that the condition is false. Now let's save it and run it again. You can see second statement, which means the condition that we gave was false. Now let's look at some special operators. Now, I already explained the size of operator in the first C video, which gives the number of bytes or bits that your variable takes. Now, an interesting thing, a star is used to declare a pointer. A pointer in most languages is something that holds or points to the address of another variable. So anything you give, now this is a pointer. Now how do you initialize it is pointer is equal to, now the other special operator is ampersand, which is used to tell the address of any variable. Now I'm storing the address of first in the pointer. Now if I put printf and %d comma pointer, let that let us delete the ternary operator line. Now let's run it. You can see it says 1, which means it pointed to the value of the variable first. Thanks for watching.